Consider a population with a mean of 40 and a standard deviation of 8. If you were to multiply every score in the population by 3, what are the new mean and standard deviation, or what will the new mean and standard deviation be? Okay, so have a look at what it is we're doing. We're multiplying by 3. We're taking every score, multiplying by 3. So if you have a look at at option A, the mean stays the same at 40 and the standard deviation stays the same at 8. So in this case, they're suggesting that both will stay the same. Whereas in B, only the standard deviation is multiplied by 3. In part C, it says we've got the mean at 120 now, and the standard deviation stays the same, so only the mean is multiplied by 3. And finally, the last option has both multiplied by 3. So which is it going to be? Well, we know from the previous example that anything that you do to your scores, the mean will be affected. Let me give you, again, a simple example. Let's say that I've got some scores. Let's say one person makes $15 an hour. The next person makes $20 an hour, and the next person you ask, they turn out to make $25 an hour. So what is the average wage, or what is the average hourly pay? Well, if you were to add the 3 of these, you're going to get 60. And if you were to take the average, this is going to be the sum of x over n. So that is how much? That's 60 over 3. The average is 20. Now, what if you were to, I'll call this little subscript n. This is my new x. My new x, let's say that I give everybody, let's say I double everybody's money. I say, okay, I'm going to multiply, the company's doing really well, I'm going to double everybody's hourly wage. So 15 becomes 30, 20 becomes 40, and 25 becomes 50. Have a look at my new sum of x. It's going to be 30, 40, and 50. This makes 120. So my new average is going to be 120 over 3. It's going to be 40. My old average compared with my new average, you can see that the new average I've doubled. I doubled all of the values, and that ended up doubling the average. So we know that the average is going to be affected. We know that the mean will be affected. So it's going to be one of these. These guys have got to be wrong, because the mean cannot stay the same when you multiply every score by 3. But what about the standard deviation? What about the variation that's measured? Well, this one I can do without math. I think you can see that for each of these workers, the difference between them is 5. That's a small amount of variation in their hourly wages. After I double everybody's salary, or after I double everybody's hourly wage, look at the difference now. The difference is 10. So there are larger gaps between their earned amounts. So what I've done is I've taken the scores that were 15, 20, and 25, where they had a little bit of space between them, and not only have I taken this entire group and moved it up, so not only have I made it everybody more money, but what's happened here, let me try and draw this on sort of a number line. 30 is my score there, and then there would be 35, and then 40, and 45, and 50, and so on, 55. Now people are making 30, 40, and 50. The entire distribution of new scores is more spread out. This used to be a small amount of variation. Now it's a very large amount of variation. So I am definitely going to see that my standard deviation, which measures variation, is also affected. It's going to be that both of these measures are affected when you change every score. When you multiply every score in the population by 3, you're not just moving them all ahead, you're also spreading them out when you multiply.